So we're in section 3.2 today, solving equations, and really it's using the distributive property. We also do have to do some combine like terms, that type of thing, but parentheses mean distributive property. All right, so in example 1, we what we're going to see in these examples is that we actually have to do steps to simplify the side of the equation that has the variable before we can do inverse operations. All right, so up until this point, we just see a problem and we can do inverse operation to solve for the variable. And while those steps will still come into play, the first thing we need to do is to distribute the 7 and get rid of those parentheses before we can get to that step. So we have negative 21 equals 7 times 3 minus x. Go ahead and write that in your notes. All right, and so we need to distribute 7 times 3 and 7 times negative x. One of the largest areas of mistake that I see when it comes to distributive property is getting your sign right or wrong. Okay, so you just really need to pay attention to those negatives. 7 times 3 is 21. 7 times negative x is negative 7x. All right, now don't let your mind play tricks on you here with these 21s. It might not necessarily be opposite. All right, and another thing that we need to be mindful of is this. All right, maybe at some point when we started equations, we could, basically solve it without doing the steps, right? So at the very beginning on those first, day or two, some of the students would just try to solve it in their head and not follow the steps. And what did I tell you? I told you that we would get to the point where we couldn't do that anymore. And we're at that point now, where it's going to be difficult to solve these using mental math. But if we know our steps, we can follow the steps easily to get to our answer. So step 1 says, what do I move first? On the side of the equation with the variable, what do I move first? 21, the number that's by itself. Pay attention to the signs. These are not opposite. Same sign, add and keep, negative 42. All right, so lots of just small things here that could lead to a wrong answer if we make a mistake. That's why it's just so important to even go back and check. Negative 42 equals, and what would I bring down from the other side? Negative 7x. There's a negative in front of there. Negative 7x. And now what would I do to solve? Very good. Divide both sides by negative 7. Positive 6. All right. Now, we don't have a homework assignment on this tonight. So, on your homework, it would ask you to check. On your quiz, checking will be optional, but you can still check this. 3 minus 6 is what? What's 3 minus 6? Negative 3. What's 7 times negative 3? Negative 21, so it checks out. I really do want you to get to the point where that's just a habit, and you can easily just check without necessarily showing the work, but you can check these. All right, so I really want you guys practicing that. All right, go ahead and do the second one on your own. Raise your hand when you have the answer. To do the distributive property first. 3 times 2 is 6. 3 times negative x? Negative 3x. What'd you do next, Wame?
I did minus 6.
Minus 6 from both sides.
And I got negative 42.
Yes, equals negative 3x. Amari, what would you do next? Okay, all right. Anybody know what would you do next? Avery?
Divide negative 3 on both sides.
Very good. Divide both sides by negative 3. And x equals 14. X equals 14. Who got 14? All right, good. All right, so that's it for example 1. Now in example 2, we're just adding another step. So now, not only do I see parentheses, but I see one additional term in here. We'll see how it plays out in just a minute. Let's go ahead and first take care of our parentheses. We have 5x, and again, sign is important. The 2 is negative. That subtraction sign in front of the 2 has to be taken into account. Negative 2 times x would be what? Negative 2x. Negative 2 times negative 1 would be what? Positive 2 equals 8. All right, so 5x minus 2x, 3x. Plus 2 equals 8. So that's what they were talking about in the title of the lesson where it said combine like terms. Sometimes I have multiple terms that can be combined, whether it's numbers or variables that I must do before I can start doing inverse operations. Now, would you agree everything is simplified, right? Okay, so now I can start my process of inverse operations. My rule says, what do I move first? 2, the number that's by itself. I move my 2, subtract it, and then 3x equals 6. Okay. And now what do I do to both sides?
Divide by 3.
Divide both sides by 3. X equals 2. All right, and I can still check. Plug 2 back, well, no, got a little crazy. Plug 2 back in for x here, and plug it in for x here. So 5 times 2 is 10, minus 2 times 1, which is 2, so 10 minus 2 is 8. All right, go ahead and do the next one on your own. When you have the answer, raise your hand. All right, so 8b plus 4b plus 20. Raise your hand if you got that far. So did you distribute correctly? All right, equals 44. But before we can do inverse operations, can we combine any like terms?
Yes.
What? 8b and 4b to make 12b. Okay, and then what do I do to both sides?
Subtract by 20.
Subtract by 20. Okay, 12b equals 24, and then divide both sides by 12, b equals 2. Who got it? B equals 2, good. All right, moving on to example 3 now. Okay, so example 3 is a word problem. It's a little lengthy, so I typed it all in there so y'all could follow along as I read it. It says your school's basketball team is playing in the championship game. For the game, the cheerleaders want to buy a banner that costs $47, and they also want to buy small items to give to the students. Pom-poms are $5.20 each, and noisemakers are 80 cents. They have a total budget of $377. If they buy an equal number of pom-poms and noisemakers, how many can they buy? It's a lot of words, but let's break it down. What does every equation have? An equal sign, so write it. Every equation has an equal sign. And then what would go to the right of my equal sign? 377. Okay, so that part we should all get very easily. Now we're going to, our next step is to look for any values that would go on the left side that would not be connected to a variable or affected by the number of something being purchased. Anybody see any numbers over there, Wame?
47.
47. 47 is just the cost of the banner. Now, the pom-poms and noisemakers, I don't know how many I can buy. So that's going to be my variable. I can choose whatever variable I want. But here's the catch. I'm going to buy the same amount. So it's the same variable. However many pom-poms I buy, that's the same number of noisemakers that I'm going to buy. Do you see that? All right, so it's the same variable because I'm buying the same number of each one of them. So I would multiply $5.20 times however many I can buy. I don't know how many I can buy yet. And then I add that to 0.8. And again, I don't know how many I can buy. Do you see that? All right, so I don't know if it's 3 or if it's 4, and I know I'm multiplying because that's how I would calculate a total, right? Like if I wanted to buy 3 pens that were $4 each, how much money would those pens be? If there's 3 pens and I'm going to pay $4 per pen, $12, what did you do? You multiplied. You didn't add 3 plus 4, you multiplied. So that's where multiplication comes into play here in this equation. So now, what do you think you're going to do over here before you can solve?
Combine like terms.
You've got to combine your like terms, which beautifully does work out to what? $6 even, because we don't like decimals, do we? All right, 47 plus 6n equals 377. So now we've made it through the hard part. I think you would all agree that setting up the word problem is the hardest part of solving. Once we have it set up, it's, home stretch now. We just go ahead and solve. So just take a minute to go ahead and solve this equation. All right, so what do I do first? Subtract 47, and then divide both sides by 6. Did y'all get 55, noisemakers and pom-poms? I had to abbreviate because I didn't have enough room. But yes, it would be 55. So kind of an odd number, but basically they could even advertise this, to the school. Hey guys, the first 55 people to show up to the game gets the noisemakers and pom-poms. So that could be even a marketing tool that they could use. So that's how I would solve that equation. Now I want to spend a little bit of time just doing classwork, walking around, looking at your papers, just see how well you guys will do on some classwork examples. So go ahead and solve these two. When you're done, raise your hand, and then we're going to do a word problem that's very similar to the one that we just saw. So on the first example, what would you do first? I don't see any parentheses, but is there anything we can simplify before we start doing inverse operations? Okay, but you said add 2n, but I see a subtraction sign there. Why would you add 2n? Because what's before the 2n? It's a positive, so you have to look at the sign in front of the term. 3n plus 2n, 40 is what's negative, not 2n. So 3n plus 2n is 5n, minus 40 equals 15. And now I'm ready to start moving my numbers around. All right, negative 40 plus 40, 5n equals 55, and divide both sides by 5. All right, n equals 11. Who got that one right? N equals 11. All right, now the second one, there's a couple tricky parts to this one. All right, 13 equals 2y. What's negative 3 times y?
Negative 3y.
Minus 3y. What's negative 3 times 4?
Negative 12.
Minus 12. Okay, who got to that point? Anybody get there? So you got through distributive. But now, what's 2y minus 3y?
Negative 1y.
Negative 1y. So that's where it gets kind of, okay, that's kind of odd because normally we have a number other than 1. Do we even need to write the 1?
Not really.
1 is understood, so I could just say negative y. I like to say negative 1y to remind myself there's a negative 1 right there. Minus 12. So now I have everything simplified. I can start my inverse operations. So what would I move first? Negative 12. Add 12 to both sides. Okay? You see, guys, how we're just taking it step by step. So when we first start the problem, when you first look at that problem up here in the original problem, it would be very, very difficult, if not impossible, at this point for us to figure out what the answer is, right? But we just take it step by step, and we end up with the right answer. Okay, so now we add 12 to both sides, and we get 25 equals negative 1y. So is that my answer? It's not my answer because a negative cannot be attached to my variable. I must divide both sides by negative 1 to get negative 25. Negative 25. Anybody get that right? Okay, good. Good. That one had a couple tricky points to it. All right, go ahead and turn in your books to page, I think it's 128. Page 128. We're going to do another word problem. So let's read number 21. It says you want to organize a group of friends to go to a karaoke studio this Friday night. You must pay $30 to reserve your room, plus $5 each person in the group. You also want to have snacks for the group at a cost of $2 per person. How many people can be in the group in order for the total cost to be $65? Go ahead and try to write an equation and solve for how many people can be in the group. So Janie, what equation did you write?
We all know
So-
cannons.
30
It's 30 plus 5, and then I put P as the variable.
Yeah,
Plus 2P equals 65.
very good. And great minds think alike. I used P too. Now, I wrote it in a little bit of a different order than her. Is that okay?
Yes.
Yeah, that's fine. So now, Lexi, what did you do next?
Oh, I did 5n plus 2n.
Yeah. And you got 7.
And then
Okay. And JC, what'd you do next?
I did,
Mhm.
changed positive 30 to negative 30.
Yeah.
And then minus 65.
Uh-huh. And then we get 7P equals 35. And Myri, what did I do last? Divide by 7 both sides. P equals 5. People, who got it right?
Boom.
Good, good. All right, so just setting up these word problems, it's a little bit of a challenge, but we'll keep practicing it. Hopefully you'll start to learn some of these strategies that can be helpful. If you understand that, that's everything you need to know for 3.2.